Okay, hello everybody. This video is dedicated to explain how to apply georeferencing tool to georeference a scanned map using QGIS Georeferencer. What do you mean by a scanned map? A scanned map is an image or a produced digital image of an old map which is already exists on paper. For example, we have a sample of scanned map, tectonic map of Iraq. The map dated to 1996, and this map is already exist on paper. Is scanned and converted to a digital form. Still, this digital form, we cannot directly use it in any GIS software because it is not georeferenced. What do you mean by it is not georeferenced? It means when I load this image to a GIS software, does not represent its actual geographic location, or the feature inside the image does not represent their actual geographic location. Another important things to remember while digitizing any scanned map is you must have ground control point on this image before starting georeferencing. What do you mean by ground control point? They are point of known geographic location. Unfortunately, on this map we have a grid, and this grid is referenced with geographic coordinate system. The geographic coordinate system, the location in geographic coordinate system is indicated or registered with a pair of values. The first value, for example, we have 49A is a eastern value and 37 is a northern value. I have extended two lines from these two values to intersect in a point. Now I know the coordinate for this point according to geographic coordinate system is 49E and 37N. There is another ground control point which is indicated in the similar way. The third one is over there. Okay, now let's load this layer to QGIS. On the toolbar, Data Source Manager toolbar, click on Open Data Source Manager. There are several tabs on this window, Data Source Manager. We activate the tab raster because the layer which we are going to load is raster type. Browse to the place where you store the layer or the file. Okay, this is the layer or the file which is the tectonic, saved with the name tectonic map of Iraq. Select and open. Click on Add. Close this window. Okay, the layer appears in the canvas area. Let's check whether this layer has a coordinate system or reference coordinate system or not. Right click on the layer, properties. From source, set source coordinate reference system. Invalid projection. There is no coordinate system or any coordinate system not specified for this specific layer. And there is a question mark. If you just move your cursor on the question mark, the tooltip says layer has no coordinate reference system set. Another check to make sure that this layer does not represent its actual geographic location in any way, just move the cursor on the point or to the ground control point and see if you read the same value on the status bar. Okay, so now I have to read 4937, but no, there is another different value on the status bar. It is 4604 comma minus 296.2. These two value does not match with the value of the ground control point. This is another evidence that this layer does not represent its geographic location. To rectify this layer or to georeference this layer and to push this layer to represent its geographic location, we use georeferencer. From raster menu, select georeferencer. The window of georeferencer appears, and the window is somehow simple, has a simple interface. From the menu bar, the file menu, we see the option like open raster, start, load, ground control point, and so on. Edit, view, and setting. And most of these options also appear as icon on the toolbar. The first things to do is uh, to set the value for setting or transformation setting. Click on this icon, transformation setting, or from setting menu, click on transformation setting. Transformation setting window appear. From the first panel, transformation type, if you click on this drop down list and you see different transformation type: linear, polynomial 1, 2, 3, thin plane spline, and so on. Which transformation is suitable for our task? It depends on the quality of the image or the scanned image. Let's explain this point. While doing georeferencing also involves transformation. What do you mean by transformation? This is an example of transformation. That this is, let's say it is the scanned map, and this is the georeferenced map. Everything is changed. The location, the orientation, and even the pixel value are recalculated. Depending on what transformation you are going to use for your georeferencing purpose, it depends on the quality of the scanned image. For example, we just focus on the three available types of polynomial transformation: 1, 2, 3. For example, this is an old map, and this an old map is scanned. Let's say this is the digital production of this paper-based map after scanning, and for any reason that the scanned image is somehow distorted. If the distortion is not significant, and if you take a look at the boundary or the edge of the map, the lines which are supposed to be straight, they are still straight. However, there is a slight rotation in the image. In this case, the proper transformation algorithm is polynomial type 1. And if the edge of the image or any straight line within the image or within the scanned image is somehow distorted and became somehow a curvature has happened in the image, So the second order polynomial is maybe a better choice than the first order polynomial. If the distortion, and for any reason, is significant, and you see that the line are extremely, these lines are supposed to be straight, but they are extremely became non-straight line. They are not straight anymore, and the distortion is significant, and in this case the third order polynomial is a better choice for your transformation algorithm. For our case, the image is somehow the scanned image is somehow reasonable, and mm, for instance, I'm going to use the first order polynomial transformation type. And the resampling, it means the resampling after uh, applying the transformation. And there are also different type of resampling, like nearest neighbor, linear, cubic spline, and so on. But if you have chosen polynomial type 1, maybe the resampling method of nearest neighbor usually goes with polynomial type 1. The target spatial reference system is the reference system that you want to define for the scanned image. And this is mainly depend on the coordinate system of the ground control point. For as we explained it before, that the ground control point now are specified using geographic coordinate system. We have two coordinate system: geographic coordinate system and projected coordinate system. They usually, when you see the eastern and northern value are registered with degree value, this represent a geographic coordinate system. I'm going to use geographic coordinate system, that means without projection, and the geographic coordinate system of WGS84 is a good choice in this situation. If you just click on this drop down list, you may find several choices. If you for any reason you didn't find WGS84, just click on this icon and look after whatever you want to specify from this menu, or just filter WGS, and the choice will appear directly here in this area. And fortunately I can find WGS84, or you may filter using this number 4326. Okay, uh, this is a definition of this geographic coordinate system, World Geodetic System, 1984. Output raster. Now the output raster is what we get after georeferencing is a new raster. This new raster is georeferenced, and the spatial reference is specified for this new raster. Therefore, I have to provide a location and a name for this new raster. For example, tectonic map georef 1. Okay, and you can see that the save as type is the similar type of the original file, which is tectonic map of Iraq. Save. Compression as default none. Save ground control point. Check this checkbox and click on OK. The second step after setting or transformation setting is to load or to open the scanned image. Click on this icon and navigate to the location where you have stored the copy of the scanned image, tectonic map of Iraq. Open. Okay. Yes. After you have loaded the image, uh, the next step is to define the ground control point. Click on this icon, ground control point, and zoom to the ground control point on the image. You have to choose this point accurately as possible. 49 easting is 49 and 37. Okay, you may see that this point appear in ground control point table. You may need, or for any reason you want to resize this window, and this column represent value, for example source x, source y, destination x, destination y. These are the value of x and y, or easting and northing, for the image which is currently displaying on the canvas area. Okay, now, and these are the value for the ground control point, which is provided by us or by the user. Now move to the second ground control point and enter the value. The third one, something to remember while using ground control point: the ground control point, when they are more than two ground control point, for example for polynomial type 1, you must have 3 or more ground control point, and these 3 or more ground control point must be not collinear, or they are distributed on the same line or direction. As we have three point, these 2 point are collinear, but this one is not collinear with these 2 points. (39, 37). Okay, after you have checked the point and you are pretty sure that the point are located or specified correctly, the next step is to run the georeferencing. Click on the icon of Start Georeferencing, or from menu, file menu, Start Georeferencing. Yes, please set out the raster name. You have to specify another raster name. Okay. Ref 1. Okay. For any reason the program did not accept that name, I have changed the raster name. Okay, now start, and you see this message: georeference successful, raster was successfully georeferenced. And eventually you see that the raster layer appeared in the layer panel. And still I'm looking at the old or the scanned image, which is not georeferenced. Deactivate this layer and zoom to the new layer. Okay, this is the same image but after georeferencing, and let's check some point to make sure that our georeferencing was successful. For example, if I move my cursor to this point, I have to read from the status bar the exact value which define this point, which is 49E 37N, and these two value is they are very close to the value appearing from the status bar coordinate, it is 49.0011 and 37.001. Okay, another check for the second. Yes, they are very close. 49.31. Okay, now after checking this control point, and it depends on you if you accept the accuracy of this transformation or georeferencing or not. If you are not happy with the result, you may repeat these steps and providing more ground control point. More ground control point make the georeferencing even more accurate. This is also true for other transformation types, polynomial 2, polynomial 3, except for providing more ground control point ensure more accurate result, except for thin-plate spline. Okay, let's say accepting this result. If for any reason that you can't see the georeferencing window, just click on this icon of QGIS twice and the georeferencing window will appear. Click on File and click on Reset Georeferencer. Now close Georeferencer window, and your layer is georeferenced and it is ready to be used in any GIS application, and it will be overlaid with other layer correctly, and it also can be used for digitizing purposes. Okay, thank you for watching.